Hello viewers, welcome to our channel. Kindly I request you to subscribe to my channel.
Laboratory, chlorine gas is prepared by the oxidation of concentrated hydrochloric acid by oxidizing agents such as manganese 4 oxide, potassium manganate 7, and potassium dichromate 7. We add a few drops of concentrated hydrochloric acid to the potassium manganate 7 solution. A redox reaction takes place, liberating chlorine gas. Water is used to remove traces of hydrochloric acid fumes, and concentrated sulfuric acid removes moisture from the gas. Chlorine is collected by upward displacement of air because it is denser than air. Physically, chlorine is a greenish-yellow gas with a pungent choking smell. It is about 2.5 times denser than air, and this explains why it is collected by downward delivery or upward displacement of air. It is fairly soluble in water, forming chlorine water, and it is easily liquefied under pressure. Chemically, chlorine is a highly reactive acidic gas. It turns a moist blue litmus paper red, then bleaches it. It reacts with most elements with the exception of noble gases, carbon, oxygen, and nitrogen. Reaction with metals. Chlorine reacts with most metals when heated to form metal chlorides. A heated sodium explodes into red-brown fumes in a flask containing chlorine to form sodium chloride. When heated magnesium is used, magnesium chloride is formed. When a heated iron wool is inserted in a jar containing chlorine, it burns with brown fumes to form iron 3 chloride. Note that when the metal exhibits more than one valency, the chloride of the higher valence is formed, and that's why we get iron 3 chloride and not iron 2 chloride. The brown crystals of iron 3 chloride are readily soluble in water. Actually, iron 3 chloride is highly deliquescent and absorbs water from air to form a solution. Reaction with nonmetals. Chlorine reacts with red phosphorus to give phosphorus 3 chloride and phosphorus 5 chloride. Oxidation properties. Chlorine oxidizes heavier halide salts to corresponding halogens. When chlorine gas is bubbled through a colorless solution of potassium bromide, the color of the solution changes to deep yellow or reddish brown, and this is due to the formation of elemental bromine as it is displaced from potassium bromide. When chlorine gas is bubbled through the colorless solution of potassium iodide, the color of the solution again changes to dark brown. This is followed by the deposition of a black solid. This happens because chlorine displaces iodine from potassium iodide. Both of these cases are oxidation-reduction reactions. In the first one, chlorine oxidizes bromide ions to elemental bromine. Chlorine is itself reduced to chloride ions. In the second reaction, chlorine oxidizes iodide ions into elemental iodine. Thus, chlorine is a stronger oxidizing agent than both bromine and iodine. This is because chlorine is more electronegative than both bromine and iodine. Again, when a gas jar of hydrogen sulfide is inverted over a jar of chlorine, a yellow deposit of sulfur and steamy fumes of hydrogen chloride are seen. Here, chlorine is reduced to hydrogen chloride and hydrogen sulfide is oxidized to elemental sulfur. By losing 2 electrons to form elemental sulfur, hydrogen sulfide is oxidized. The 2 electrons are gained by chlorine, which is reduced to chloride ions. Chlorine is the oxidizing agent. We can also say that hydrogen sulfide is oxidized by losing hydrogen and chlorine is reduced by gaining hydrogen. When ignited, ammonia reacts with chlorine, forming hydrogen chloride and nitrogen. In this reaction, ammonia is oxidized to nitrogen by loss of hydrogen atoms. Chlorine is reduced by gain of hydrogen atoms. By donating hydrogen atoms, ammonia is behaving like a reducing agent. By accepting the hydrogen atoms, chlorine is behaving like an oxidizing agent. When chlorine gas is bubbled into a solution of iron 2 chloride, the color of the solution changes from pale green to yellow. This is due to the formation of iron 3 chloride. In this reaction, iron 2 ion is oxidized to iron 3 ion by loss of an electron. The electrons are accepted by a chlorine molecule, which becomes reduced to 2 chloride ions. The net ionic equation is as follows. By accepting electrons, chlorine is acting as an oxidizing agent. When bubbled through water, chlorine dissolves, forming a pale yellow solution called chlorine water. Some of the chlorine reacts with the water to form a mixture of hydrochloric acid and chloric 1 acid, also called hypochlorous acid. When exposed to sunlight, oxygen is liberated. As we stated, chlorine water contains a mixture of hydrochloric acid and hypochlorous acid dissolved in water. Hypochlorous acid decomposes slowly to hydrochloric acid and oxygen. Bleaching action of chlorine. Chlorine is a strong bleaching agent. When the wet blue litmus paper was inserted in a glass jar of chlorine, it turned red and then white, which indicated that it was bleached. Equally, when flower petals are inserted in a flask containing chlorine, they are bleached after some time. The bleaching action is a result of hypochlorous acid, which is formed when chlorine reacts with water. Hypochlorous acid is unstable and decomposes to hydrochloric acid and an oxygen atom. Free oxygen atoms are highly reactive and they combine in twos, forming oxygen molecules. In the presence of a dye, the oxygen atom formed by the decomposition of hypochlorous acid reacts with it to form an oxidized compound, which is colorless. In the absence of water, hypochlorous acid is not formed, and this explains why we used a wet litmus paper. Moist chlorine will bleach many other materials like writing ink. It will, however, not bleach printing ink, which is made of carbon. If you recall, we indicated that chlorine does not react with carbon. The bleaching action of chlorine is different from that of sulfur dioxide. Whereas chlorine bleaches dyes through the addition of an atom of oxygen, sulfur dioxide bleaches dyes through the removal of an oxygen atom. In other words, chlorine bleaches dyes by oxidizing them, while sulfur dioxide bleaches dyes by reducing them. Reaction with alkalis. When chlorine gas is bubbled into a solution of dilute sodium hydroxide, sodium hypochlorite and sodium chloride are formed. When chlorine gas is bubbled into a solution of concentrated sodium hydroxide, sodium chloride and sodium chloride are formed. Sodium hypochlorite, like hypochlorous acid, is able to bleach dyes. In the presence of a dye, it decomposes, releasing an oxygen atom. The oxygen atom combines with the dye to form an oxidized compound which is colorless. Most of the common household liquid bleaches, for example Jik, contain sodium hypochlorite as the active ingredient. If chlorine gas is passed over dry sodium hydroxide, that is slaked lime, a solid substance called bleaching powder is formed. Bleaching powder contains about 36% available chlorine. Chlorine is released by reacting the powder with dilute acids like nitric acid or hydrochloric acid. When exposed to the atmosphere, bleaching powder smells strongly of chlorine and deteriorates quickly. This is because it reacts with atmospheric carbon dioxide, releasing chlorine. Test for chlorides. A white precipitate is formed when silver nitrate solution is mixed with a solution containing chloride ions. This is due to formation of silver chloride, which is insoluble. Dilute nitric acid is added to the test solution so as to react with any carbonate present, forming carbon dioxide. This is necessary because if a carbonate is present, it will also form a white precipitate of insoluble silver carbonate. When excess ammonia solution is added to the precipitate, it dissolves due to formation of a complex but soluble ammonium salt. Chlorine is used in the manufacture of plastics like polyvinyl chloride, commonly called as PVC, which is used for making pipes, chairs, and tables. It is used in the manufacture of bleaching agent used in the pulp and paper industries, as well as in the textile industry. Such industrial bleaches consist mainly of calcium hypochlorite. Chlorine is also used in the manufacture of domestic bleaches, which consist mainly of sodium hypochlorite, like Jik. Again, at low concentration, chlorine is used for killing microorganisms or sterilizing in domestic water supplies. A higher concentration is used for sterilizing swimming pool water. It is used in the manufacture of chlorinated organic compounds. These include the DDT, which is used as an insecticide. Note that the use of DDT has been discontinued in many countries of the world because of its pollutant effect on the environment. Others include tetrachloromethane, 1,1,2-dichloroethane, and trichloroethanol. It is used in the manufacture of weed killers such as sodium chlorate and manufacture of hydrogen chloride, which is dissolved in water to form hydrochloric acid.